Hey, my name is Dr. Mark Hobson. I am a retired university dean, a college professor in retirement, an ordained minister, and a Christian writer of fiction and nonfiction books. I trust in God and believe in science, and I respect all people and their traditions. Educational neuroscience and andragogy, as it specifically relates to how adults learn. Today's presentation is a sharing of my research with Dr. Mariale Hardiman of Johns Hopkins University in Maryland called the Brain Targeted Teaching Model. As I In the latter part of my career, I became deeply interested in neuroscience as it relates to how adults learn best. I wanted to be a better teacher and a better course designer. So I went back to school. I got something called a CAGS or a CAGS in the brain targeted teaching model of mind, brain, and education. This is a collaboration of neuroanatomy, right? The neuroscience of our brains, education, and the cognitive and developmental sciences. So we need to consider that our mind is our psychological sense of self and personality. Our personality is right here in our prefrontal cortex. If we got into a car accident and this got damaged, our basic core personality would change because our neurons would no longer be in place. And our brain, though, is the nervous system and the controller and the coordinator of all of our mental and physical systems. And as people involved in higher education, we need to realize that we teach brains and not feet. And so this presentation, which is part one of three parts, I'm going to explain some basic neuroanatomy and the blending of neuroscience and education into what I hope to share as six strategies in teaching and learning science, or learning science, let's call it that, of this brain targeted teaching model that Dr. Hardiman at JHU researched over 20 years of her career. So there's two really poignant quotes up on this screen that say, in all areas of education and training, we teach brains, and educational professionals who know more about the brain will enhance their performance. And here's something that's really important is that all learning, it goes through our brains, but not all teaching is targeted at our brains. So as instructors and learning designers and any kind of educational professional and trainer, we need to focus on how do brains learn best and how do I design and deliver my information in such a way that it will make it memorable for people. Also, Dr. Ernest Boyer was a brilliant higher education person, and he was president of the Carnegie Foundation for the Advancement of Teaching. And he made this great quote that has stuck with me ever since I completed a master's in education that said, learning begins with what the teacher knows. And I am doing exactly that. I am sharing with you what I know based on the scholarship of great teachers and professors who helped me learn. So this part one that I want to share with you today is called the ABCs of neuroanatomy. And I'm going to talk to you about brain structure, brain facts, how our brain lobes interact, our brain cells and our structure. And then I'm going to stop at plasticity, learning, and memory. And then we'll take up again in part two. So here we go. If you put your two fists together like this and you looked at it down, that would be about the size of your brain. It's roughly the size of a grapefruit. And it consists of about 78% water, 10% fat called glial, and about 8% of protein. So our gray cells are neuroglia. They're literally like a glue. But our white cells are neurons, and that's what we learn with. Our brain uses almost 8 gallons of blood an hour, and that's where the 64 ounces of water per day concept comes from. It's from neuroscience. Our brain uses 64 ounces of water a day. You want to learn better? You want to feel better? Then drink 64 ounces a day. Our brain is 2.5% of our body's total weight, or 3 pounds, but it uses up 20% of our energy, and it can light up uh, a 20-watt bulb like in a refrigerator. That's the power that we have in here. The concept of a dim bulb is that truly our brains can light up a dim bulb. And our brains are incredibly fast, faster than any system that science has built so far. In this slide, I want you to see that the cerebrum is the biggest part of your brain structure, and it's right underneath your skull. The diencephalon is in the middle part of your brain, and that's the part that controls a lot of learning, memory, and emotion. The cerebellum is in the back part of our brains, and it's one of the oldest part of our evolving brain along with the brain stem. These areas control autonomic functions like breathing and heart rate and blood circulation. And so it's important to keep students relaxed in the classroom so those factors aren't trying to work, because then the students are going to be anxious or upset. And through evolution, the areas of the brain that I'm showing you have contributed to learning in a positive way via movement and rehearsal. And this area that I'm appearing here, it helps us to learn by doing. Above the brain stem is the limbic system here in that diencephalon. And the limbic system is between our emotions and our cognitions. And it's an influencer or a gatekeeper of how we learn, because these areas influence everything that comes in through our eyes and our ears and our senses. It all passes through our emotional state before it becomes learned as part of an intellectual area and long-term memory. And the diencephalon also includes our thalamus, our hypothalamus, and certain thalamic nuclei. And this keeps our body in homeostasis, where we are feeling good, we are focused, and we're enjoying what's happening around us. And the cerebrum, that part that I spoke about quickly, this is the largest part of the brain, and it's responsible for all of our conscious thought, our processing, our voluntary movements, and everything about us that makes us a higher cognitive, functional person. How are you so far? Hopefully we're good. I'm going to keep moving now, and I'm going to talk about neuroanatomy and our lobes. And this little screen information is borrowed from Johns Hopkins Medicine School. The main functions of the brain are to keep us alive and to help us learn. And the more we learn, the more our chances are that we'll live a long life. 90% of all of our learning comes through our eyes, and 5% comes through our ears. So to appreciate the strategies of the brain-targeted teaching model, we benefit from understanding how our brains expand and grow during learning. So we see here the four lobes and the cerebellum, and I'd like you to think of an acronym of POTFF. So parietal, occipital, frontal, and temporal lobes. The parietal lobe processes sensory information from the opposite parts of the body. So my left side controls my right side, and my right side, I should have done it. My left side controls my right side, and my right side controls my left side. It helps position our body in space. It helps us to measure and approximate the size of objects, to grasp them, to feel them, to give us our place in space. The occipital lobe also processes sight information with previously stored memories that are in the lobe back here. So the information comes in through our eyes, passes through the middle part of our brain in terms of our feeling systems, and then goes to the back of our brain for long-term memory. So front of mind, right, or top of mind, and then the back. The temporal lobe processes visual and auditory information and spoken language. And the frontal lobe is the thinking center for working memory and higher order problem solving, language, and speech. And as I said earlier, the brain development is evolutionary, and the lower parts of our brains developed first, and the higher parts of our cerebrum developed last. The limbic system In the middle is all about emotional processing and has a surprising amount of functional area for learning. Let's go there next. There are four major parts of the limbic system, and they're called the thalamus, the hypothalamus, the hippocampus, and the amygdala. These connect the lower parts of the brain with the higher cerebral cortex functions like cognitive thought. So evolution provided a quick route to learning through an immediate emotional response. If the amygdala senses a threat, it triggers the hypothalamus to activate hormones, our blood pressure to go up, and our muscle contraction to get us ready to move. The emotional system hijacks the signal. Let me give you a quick and real example. 5 years ago, we moved to our new home in Rochester, New Hampshire to be near our son, the wonderful Dr. Luke Hobson, who moved out here with his wife, Carissa, and they now have their beautiful daughter, Riley Rose, who is our grandchild. And I was in this backyard out here, and the grass was probably 12 to 16 inches tall. No one had lived in the house for 2 years, and I had to mow the lawn. And as I'm mowing the lawn, I started to think to myself, I don't really know this area. I wonder if there are any animals or critters or even snakes in this lawn. And I ran over this object that bounced up in this way and looked to me just like a snake, but it was just a stick. But in the interim, I had shut the lawnmower off and ran into the garage because my brain was saying, that's a snake. You don't like snakes. You don't know these snakes. Get out of here. Interestingly, that can happen in the classroom. Like you've never seen calculus before and you're in a calculus class and everything just feels overwhelming. And so you just want to either hide or run or get away, perhaps. So if the professor understands that you have these kinds of emotional system hijacks, they can redirect their teaching and learning strategies to support you through that anxiety, right? And if you're a learning designer, you can do the same thing. If you're a trainer in a corporate environment, you can do the same thing. So creating an emotionally safe climate for people to learn, to grow, supports creativity and imagination and spontaneity. Secure and happy students learn better, and stressed students struggle. Let me share little more about this information in terms of the hippocampus and the amygdala. Once the information moves from the prefrontal cortex, it goes through the middle of our brains, and our hippocampus will hold that information for nanoseconds to minutes in like a working memory. And then eventually, if we are telling ourselves that this information is good for us and we want to know it, the hippocampus will then move it forward into longer term memory in our cortex. And this is called neuroplasticity. How this happens is in chunks of information, and we all know about, most of us should know about teaching and learning chunks of information and designing classes in such a way. But think about this in terms of a phone number. How many numbers can you remember at any one time? Here's my cell phone number. It's 603-860-1380. And I remember it without looking at my phone. Will you remember that number after this presentation is over? Probably not unless you focus on it and you make it important to you. And your hippocampus says, they're saying that this is important and I need to remember it. So let's do that one more time. 860-1380. Now let's move that into long-term memory. So most of us can hold chunks of information up to about 9 or 10 digits, and that's in our working memory. And if it's important, our hippocampus will move it into long-term memory. Now let's talk about the amygdala. The amygdala, as I said, is all about that threat to emotional systems or threat or danger, but it also does something else. And that is that if you are frustrated, stressed, or bored, the amygdala will shift you down so you will learn less and dislike the information. So we, as instructors, designers, educational professors, we need to keep the amygdala happy And one way that we can do that is to connect what our adult learner currently knows with new information or novelty to keep their interest. And we're going to talk more about that on the next slide. But before we leave, I want to talk to you just a little bit about the hemispheres of our brain, because there are lots of neuro myths out there that people are right brain thinkers or left brain thinkers. It really doesn't work that way. We use all of our brain all day, every day, just to get through the day. Evolution, though, caused something interesting to happen with our hemispheres. And that is that it caused 90% of human beings to be right-handed, meaning that they're using the left side of their hemisphere to accomplish that physical act. And that means that left-handed people are using the right side of their hemisphere. And because of evolution, that tends to make left-handed people, are you ready for this? A wee bit smarter and more creative, because they have to work harder to get the information processed. They have to push back against evolution. I've done a lot of research on this, and you'd be surprised at the amount of US presidents that are left-handed as well as some incredible major thinkers in history. Okay, enough trivia. Let's move on. And now, almost done. Want to talk to you about something that is really neat, actually, and important. I shared this slide today on LinkedIn. We can grow our brains bigger for the rest of our lives, all day, every day. All we have to do is a little something called read and learn and memorize. I like to call it the 4 R's of reading, reciting, rehearsing, and remembering. Because if we read it and we recite it out loud and we rehearse it and we use it, we'll remember it longer. And that part of our hippocampus and amygdala will say, oh, this is important to them, push it into long-term memory. Neuroscience has shown that brain learns through these connections between axons that send signals that are received by dendrites, and then over there, learning takes place. And the more we practice or repeat the learning, it reinforces these connections through something called a myelin sheath, and that changes the structure in the brain. The more connections are made, the faster and more efficiently the signals move, and that facilitates learning because the brain is a muscle. So let's do this one more time. If I could put a CAT scan right now in your brains and watch you learn this information, I would see your exons or an axon reaching out to a dendrite. I would then see a pop of light take place. And I would also hear a noise, a little type noise. So a flash of light would go off, a popping sound would take place, and then the myelin sheath would wrap around it like insulation and say, oh, this is really important to them. We need to make sure we remember it. So the more we repeat information, the neural pathways gets thickened as part of the cerebral cortex, and our brain gets bigger. Neuroplasticity takes place. We get bigger, we get stronger. I think about this in my own life. I have 7 degrees and I just can't stop going to school. I have 3 masters, a PhD, and 2 certificates of advanced graduate studies because I just love learning. And the more I learn, the better I feel. If you are a learning designer or an instructor or a corporate trainer, you want to make your learning environment a happy, colorful, novel place so people will enjoy it and lots of popping and lighting will take place in their brains. Let's close here on slide 8 on plasticity, learning, and memory. We talked about this a little bit. Neuroplasticity occurs when we learn new material called novelty, and the brain evolves through learning. There was this seminal study done back in the 1980s before there were GPS systems, where London cab drivers were taught a way of learning all of the streets and addresses in London as part of their work. And they became very specialized in this information. And there was testing done on the size of their hippocampi compared to bus drivers who just followed routes. So the bus drivers knew where they had to go every day, where the cab drivers were always being challenged. So those cab drivers, because they had to learn new and more and better information, literally had bigger brains. So there is short-term memory, information that we use and we retain for about 30 seconds, usually in chunks of 9 or 10 elements. And if it's really important to us, then it will move in to working memory. And in working memory, there's information that we want to use for executive functions, and that generally takes place up here. And so what do I have to do today? Let me write that down. There's my 5 things. And 5 to 7 items in working memory, things I want to do in one day. That's plenty. And our capacity is around 7. And then we get a little emotionally overloaded. But long-term memory is when information moves from my working memory to long-term memory storage in my cerebrum. And that always happens if my hippocampus and my amygdala says, he's happy with this. This is important to him. I'm saying him as in me. And so we need to remember. So short-term memory is like a simple Excel formula or a phone number. Working memory is temporary, but allows us to perform executive functions like planning, organizing, rehearsing. The average brain chunk here is 7 to 9 items. And then long-term memory is if the brain perceives that learning, for example, a trial balance listing of ledger accounts for all debits and credits in a city the size of Manchester, New Hampshire, where I worked for 10 years. My PhD is in business. I had to learn all of these crazy ledger account numbers. I needed to know it. And so I did. I memorized them through long-term memory. Now, when a student remembers something for the long term, that's called LTP. When I say student, I mean an employee, your learner, whoever your learner is. And LTP is really the gold of what we want to help accomplish, where that person can just remember the information because we've got a really good design of a course and we've got really good assessments that have reinforced the information to them. And we've used really important types of reading materials that would move it forward. And also as an instructor, we help them to read, recite, rehearse, and remember because we're not acting like the sage on the stage. We're having them use the material so it will help them to remember it. This is my email, and we're going to continue this presentation next time. And I want to tell you more in the next message about teaching strategies using the brain targeted teaching method. And now I'm going to stop sharing my screen and say goodbye. I hope you enjoyed this presentation. I think we're like maybe about 20 or 25 minutes. And I'll be back in a few days with the next segment. And I have a website. Most of the website is about my other job of being a Christian writer. But if you want to check it out, it's www.drmarkhobson.com. And my email is drmarkhobson@gmail.com. It was a pleasure talking to you today. Have a great day.